Hello everyone, I am Anjan and welcome to the 22nd video tutorial of the Verilog course series. In this video, you will be getting to know how a 4-bit comparator will work and how to design a Verilog code for it. For a better understanding, I split the video into 3 parts, that is pre-coding part, coding part and the post-coding part. Let's move on to the pre-coding part. In the pre-coding part, you will be seeing the circuit diagram and the functionality of the 4-bit comparator. Coming to the functionality of the 4-bit comparator, you will be seeing 8 inputs and 3 outputs, and these 3 are like this, just negligible, you don't consider it. I also didn't consider these 3 inputs in designing of my Verilog code. And for a traditional 4-bit comparator, we will be having 8 inputs and 3 outputs. And coming to the 8 inputs, they are divided into 2 parts, that is first 4 and second 4. First 4 is considered as a single binary number with 4-bit, and second 4 numbers are considered as 4-bit binary number. Like say it is 1, it is 1, it is 1, and it is 1. Total it is 1 1 1 1. The whole value of A equal to 1 1 1 1 1 1, 4 ones, and the whole value of B equal to 0 0 0 0. Let us take an example. So the hexadecimal value of this is 0 and this is 7, so 7 is greater than B. So finally the output will be this one, A is greater than B. Then we will get 1 at here and 0 at here and 0 at here. This is the output. If it is reverse condition, then we will be having 1 at here, 0 at here, 0 at here, like this condition. Let's move on to the coding part. Here I declared my module name as _4PC, and here are my inputs, the 4-bit A and 4-bit B, and output as declared in the form of registers Y00, Y11, Y22. You can also consider as Y0, 1, 2, but here I consider Y00. There is no problem at all for that. And here is the procedural block, that is always block, and here I used if statements, not else if statement. You can also use else if statement, but for a better understanding I use the if statement. If A is double equal to B, you should note that you should not use single equal to, because it is a logical operand. And if this is true, then Y00 equal to 1, and all the other statements are equal to 0. Y00 represents A equal to 1 B, and Y11 represents A less than B, and Y22 represents A greater than B. And this is the procedure of my Verilog code. And here I entered the module. Let's move on to the post coding part on the tool. Here is my Verilog code, and here I pre-simulated it for you. Let's check out for some values. Let's take the same example which I taken earlier. I will take 7. Oh, it's 4-bit, not 3-bit. And I will take it as 0. Now the output will be A is greater than B, so we should get A is greater than B means Y22 equal to 1. Let's run it. Y22 equal to 1. You can also reverse those values, like put 7, show that you will get Y00 is 1, because Y00 represents A equal to B. You can change it to 0 so that you will be getting y11 as 1. Here it is, y11 as 1. Now let's move to the schematic part. Here is the schematic part, bit complex because it is generated by the tool itself. Just note there will be 7 cells and 11 input output ports, and here are my inputs A and B. You can also give it as individual bits like A0, A1, A2, A3, but the complexity of the code will increase if you given like that. And here are my outputs y00, y11, y22, and here it is. And if you are willing to explore more on Verilog code, Verilog questions, you can check out in the description box below to explore more on Verilog questions. And if you like the video, do hit the like button below and share it to your friends, and subscribe to the Start Scratch YouTube channel. Thank you.